Hi and hello. In this video, the first in our series on properties of triangles, we'll talk about the interior and exterior angles. First, let's explore the sum of the interior angles. Now, many of us may already know that the sum of the interior angles of a triangle is 180 degrees. But I thought it'd be interesting to actually prove that, to start without knowing what the sum of all three angles is. So instead, let's draw a line. Over here at angle 2, I want to draw a line. Now I want this to be parallel to the bottom side of the triangle. I want it to be parallel to the bottom side of the triangle, and I want it to run through that angle. And here's why. Because these two lines are parallel, that means this angle right here, let's call it angle 4, is alternate interior and congruent to angle 1. And this angle, let's call it angle 5, is alternate interior to angle 3. So those are also congruent. Because angle 4, angle 2, and angle 5 form a straight line, the sum of those three angles must be 180 degrees. Then because angle 1 and angle 4 were the same, I can just substitute that in. Because angle 3 and angle 5 are the same, I can substitute that in. So the sum of all three angles of a triangle is 180 degrees. If we know any two angles, we can always find the third. So suppose, for example, we have some sort of triangle like this. If we've got 120 degrees and 20 degrees, we can find our last angle, 120 plus 20 plus some number is equal to 180. And then we can solve by combining like terms and subtracting. The two angles we know have a sum of 140 degrees. That means our missing angle is 40 degrees. Now this should be a background fact. We should already know this. What I'd like to do is I'd like to try to apply this. I'd like to find out what the sum of the interior angles of other polygons are. And we'll do this by splitting them into triangles. I'm going to try to split them into triangles where all of the corners of the triangle are made up of corners of the original shape. So splitting into triangles like this is not allowed because of those 2 points. So I can only make one triangle out of a triangle. However, if we come over here to a quadrilateral, a shape that has 4 sides, I can split it into 2 triangles, right? If I split it right here, I can make 2 triangles. A pentagon, next one has 5 sides. I can cut this top triangle off right here. And then our bottom half is a quadrilateral. So this pentagon with 5 sides can be made into 3 triangles. All right, let's go over to a hexagon. Here we have 6 sides. So there's a triangle I can cut out. Here's another triangle I can cut out. And there's a 4th triangle if I split that last one in 2. So with 6 sides, I can make 4 triangles. This next one is a heptagon. It's got 7 sides. And I can make 1, 2, 3, 4, 5 triangles. And finally, with an octagon. If I snake my way through, making each triangle have all the 3 corners on corners of the shape, there are 6 different triangles I can make. So now, because a quadrilateral has 4 sides and 2 triangles, if I add up all 180 degrees from both triangles, that gives me how many degrees all of the angles are of the shape, because all of the angles are already angles of the quadrilateral. So we're at 360 degrees. For a triangle, we had 3 sides. It could only make 1 triangle. For a pentagon, it had 5 sides. With 5 sides, we could cut it into 3 triangles. And that means that if I multiply 3 by 180, that gives me the sum of all of the angles, so 540 degrees. Moving along, a hexagon had 6 sides. We could cut it into 4 triangles, and 4 times 180, because there's 4 triangles, will give me the sum of all of the angle measures, which is 720 degrees. Now, hopefully, we're noticing a pattern here that I'd like to apply to a decagon. A decagon is a 10-sided figure, so it looks like the number of triangles is always 2 less than the number of sides. So if our decagon has 10 sides, that means I can cut it into 8 triangles. And then 8 times 180 will give me the sum of all interior angle measures. 8 times 180 is 1440 degrees. So in general, if a polygon has n sides, if it is an n-gon, the sum of all of the angles is equal to n minus 2 multiplied by 180. That'll give you the sum total of all of the angles. So if we know how many sides a shape has, and we know all but one angle, we can find the last angle. Or if all of the angles are in terms of x, you can find the sum and then solve for x. And one last idea about the interior and exterior angles of triangles is the exterior angle theorem. So an exterior angle on a triangle is the angle formed when you extend one side beyond the triangle. So I've taken this bottom side here and just extend it beyond, creating angle 4 on the outside. Remote interior angles are then just interior angles that are not adjacent to our exterior angle. So if angle 4 is our exterior angle, 1 and 2 are remote interior angles. Now, 2 things that we should know. Angle 1, angle 2, and angle 3, and angle 3 add up to 180 degrees. Angle 3 and angle 4 also add up to 180 degrees. That means that angle 1, angle 2, and angle 3 are equal to angle 3 and angle 4. Right, they're both 180 degrees. But both sides of this equation have that angle 3. Those can cancel away. So angle 1 and angle 2 add up to make angle 4. This is called our remote exterior angle theorem. The measure of the 2 remote interior angles is always equal to the measure of the exterior angle. So in this diagram, this exterior angle is equal to the sum of the remote interior angles. If those two are 60 and 40, this angle is 100 degrees. And now I can go through and I can find all of the other exterior angles if I know what the third interior angle is. Because all 3 angles of the triangle have to add up to 180, 60 and 40 is 100, which leaves you with 80 degrees left over. So now this exterior angle is equal to the sum of its 2 remote interior angles, 80 and 40. which is 120 degrees. And finally, this exterior angle is equal to the sum of its two remote interior angles, 80 and 60, which is 140 degrees. Finally, let's do a little bit of algebra with it. Again, the exterior angle is equal to the sum of the two remote interior angles. So in this diagram, 145 is equal to 2x plus 5x minus 2. If I combine like terms on the right-hand side, we have 7x minus 2. If I add 2 to get x by itself, that's 147 equals 7x, and then dividing both sides of the equation by 7, we end up with x equals 21. Now we can check our work by plugging x in. If x is 21, then this angle 2x is 42 degrees. If x is 21, then this angle is 5 times 21 minus 2, which is 103 degrees. And 103 plus 42 is 145. Thank you so much.